modular programming in LabVIEW. So I will explain you what is modular programming first. Means what is a modular design. Okay, so then I will tell you what will be happens, what we do in LabVIEW to have that kind of design in our program. Okay? So this is what it is called modular design. Means it is a design which creates the things from different parts. Okay, so it has a different small parts, but when we collect it together, it will make different thing. For example, you can see it here. Like we have like small things. You know the Lego parts, right? So this block is similar. Means like everything is looks same, right? So all things are same, but it has a one interface which can be connected to other parts, right? Together. So if we combine it with a different way, we can able to make different things. For example, you can make a pillar, or you can make a snake, or you can make a robot also. Okay, so it's on you. Means how you can imagine, that way you can design, right? So modular design means what? You create small things. Okay, the small parts which can be connected to each other. Okay, but to connect to each other, you should have standard connections with each other. Means even there are two parts, when you connect, everything should be able to connect to each other, right? So that is called interfaces. So we make parts, we have standard interfaces which all together will make different things. Okay, and how you imagine, that way you can create the thing with that. So this is called modular design. Means, so what is the benefit of that? Means like if we design in modular way, then what will be the benefit for us? Like if we do short VIs and then after that we combine together, that will be like giving this kind of easy uses. Like it can be customized afterwards. Like when you make a final VI, but you think you thought at the end that yeah, that block can be changed so that the final output can be different. Okay, so this way you can have the customizability. Also upgradability means after designing the final block, in this way, like if you have smaller blocks coding and after combining you make a different bigger block, then it's easy to upgrade. Means for example, afterwards you understand that this block, if we had this kind of calculation differently here, this block can be of different type. Okay, so instead of arranging all the things inside this block, you go and change inside this one. Okay, so this way you will have like no need to open all those things, just edit here and you will get a better block here. So this is called upgradability. Means you can easily upgrade the things. Okay, and this quick repairable means like if you find some errors, as you have the blocks, you know the error is coming from which block. So instead of analyzing all the system, you go for particular block and analyze that to correct the error. Okay, so it's not like you have to open all the blocks, right? So this is, and reusable means like for example, you use this block here, but as you know this has a particular function, you can use this block here also. So this way you have this all the benefits of this modular design. So this can be also possible inside the LabVIEW. Okay, so how this Lego is modified altogether to make a different designs, this can be possible inside the LabVIEW also. Okay, so we will see how it is done. So as I mentioned, this LabVIEW has a modular design inside itself. Okay, so how it is done, I will show you. So LabVIEW's best power is called hierarchical nature. You know hierarchy? Hierarchy means like you have somebody on top, then they're on the
Yeah.
bottom, then there are bottom. So this is called hierarchy, like steps, layers, layers, layers. Okay, so that is called hierarchy. And the LabVIEW has, so we have the layers, different layers in the LabVIEW. So you design this bottom layer, and then you combine afterwards to make another layer and then another layer. In LabVIEW, you can use one VI in another VI. Okay, So when you use it like this, it is called SubVI. It's possible in LabVIEW, and this allows LabVIEW to become modular in design. So you can use VIs on another VI, and there is no limit. It's like you use one VI in another VI, and that VI, which has already one VI, it can be used in another VI. So it's like layer by layer. Like you can have multiple layers, but you can use it. There is no limit, like how many layers you can have. And as mentioned in the last slide, it helps you debug the blocks very easily. Means if you get error in the VI in LabVIEW, it will tell you, LabVIEW will tell you like which block is giving you error. So instead of going through all your application, we just go to that VI and analyze what is the error. Okay, so that is the benefit of having this modularity in LabVIEW. Okay. So I will give you some example of that, how it is done in LabVIEW. Okay. Yeah, so what I was mentioning is like this. So this is a VI, okay, one VI, okay, and this is block diagram of the same VI, but it has another VI. It's called SubVI. This VI has another VI, okay. So when you double click on this VI, you will get open the another VI, okay, the SubVI. You see, this name is the same, okay. So this is SubVI, right? So this is one VI. Inside that VI, this was the SubVI. When I open this SubVI, this is the SubVI. Okay? So SubVI will have some coding inside that. Okay? So this it's possible that this VI can also have some SubVI. Okay? So similar that you can have layers and layers and layers. Okay? It is similar like in other languages we use functions. You know, in one main program we use different
Yes,
functions.
functions. Yes.
So when we open VI with SubVI inside, and if you want to open SubVI, okay, just double click on that VI. Okay, just double click it will open the front panel, and its block diagram will be along with that. Okay, so this VI can have the another VI also. It depends on how complex is the program. So there will be icon for the VIs. Means all VIs have this icon. Okay. This week, the front VI was also having some icon. It is the default icon, and this is some another icon which was designed in the lab itself. When you open a VI, this is the default means like LabVIEW VI, okay, icon. So it is a default icon, right? So here VI, it has a sub VI, and when we open sub VI, this there that sub VI also has a front panel and block diagram. Okay, and this sub VI, when we put in another VI, this icon is appear as an icon for that VI as a function on this VI. Okay, so if I don't design this, it will look like this also. Okay, this will be the same as this block. Okay, so I just want to differentiate how my VI is different from this normal VI. Okay, okay, and we can write it or we can draw it on that. This VI is doing some functions, so we can name it as per our wish. Okay, and this all the VIs have the icons also. Okay, this is icons, and this is particular thing is called connector pane. Okay, this is used to input and output the values to this sub VI. Okay, so for example, I show you here. Okay, so you see the example. I will explain what is the example first, and then we describe what is happening. Okay, so here some function is there, some data acquisition which collects the temperature from outside. Okay, and I use this temperature to calculate the temperature in Fahrenheit. Okay, so this device gives me a temperature in degrees Celsius, but my user or myself, I want it in Fahrenheit. Okay, so I use this value, okay, and calculate by this formula to get a Fahrenheit value of that temperature. Okay, and this will give me initial temperature of my device. Okay, and I will continue these measurements afterwards also. Okay, so when I start while loop, okay, it will measure in degree Celsius and calculate in Fahrenheit. Okay, and when I want to choose, like I want to choose in degree Celsius or in Fahrenheit, I switch this button, and this way I will get temperature in degree Celsius or in temperature in Fahrenheit in this block.
There is a triangle. How do you understand the triangle here?
Yeah. This is a function called select function. Okay. Okay. So when you send it true value, it will choose the top one. Okay. When you select in the false value, it will select the false value and send it out here. Okay. So these are the two blocks which has the similar things. It does the similar things, but it does the twice. Okay. And okay. So how about I use this? Okay. So I designed one SubVI, okay, which takes values from degree Celsius and gives out as final VI in Fahrenheit. So this is how you use SubVI. Means if you see like there is some part of your VI which has a repeated things, so you just make that repeated thing once. So the best logic of programmer is that you don't need to write the same coding for twice. Okay. So this way you have like you design SubVIs, like used for SubVIs for different purposes. For example, if you are getting very crowded calculation in one VI, you just make it SubVI, and instead of that crowded calculation, you put one block here. Okay, so that also helps you simplify your VI. Okay, so now I will show you what I did. Like for example, this one here. So this is the block diagram of this VI. Okay, so use take temperature value as a control and output temperature in Fahrenheit. Okay, and this is the same calculation what we was doing here, and I put it here, so I don't need to calculate here and here. SubVI looks front panel block diagram same as this VI, but it has a smaller functionality. Okay, it can be used as inside different VI. Means now I use this SubVI here. Okay, but if I in future, if I going to design like one VI where I just want to calculate one point of entered temperature and calculate it in degree Fahrenheit, so I can use this VI into another VI also, that VI also, not only this VI. Okay, so that way I have like modular design now. So this is one part which can be used here or in another VI also. So how to make a VI, SubVI? Okay, so just as usual, we do prepare VI as usual. Okay, so design front panel, design back block diagram. Okay, and then when we finished with our calculations or with our testing with this block diagram, we go to next section. We call this build an icon for this VI. Okay, so it will be like a graphical representation of your VI into another VI. So when you start with your VI, okay, it will be default icon. Okay, so you just double click on it. For example, this one, you get this kind of this icon editor. It is called icon editor. Okay, okay. So when you design this like this icon will appear into your VI. Okay, so for example, you can write it like here. You put some text. Okay, so next thing is like we define called connection pane. Okay, connector pane for your VI. Okay, so when you put this block onto another VI, okay, it has to have some inputs and outputs, right? This is called connector pane. Okay, so this is connector pane, and when if I want to give input and output for this particular SubVI, I have to connect this to this one, so that when I put this VI onto another VI, I will have some input and output lines for this block. Okay, you have to connect input is like this and output like this. Like when you want to put output, click here and put it here. So there is a one what you call constraint here. We always put inputs on the left side, okay, and output on the right side, okay. So control is input and indicator is output. So click it here, click it here. It will be like connected, like this point belongs to this. And when we want to connect this here, we click here and connect here, okay. So this connection pane enables us to define connections for VI, okay, as inputs and output, okay. So this connection will appear on your VI when you put that sub VI onto that VI, okay. So inputs as controls, outputs as indicators, okay. Yes. So this is what I am saying now. So these are the connection panes, means how many you want, you can select which one you want. For example, this one you see, there is no input, no output, okay. So it is just block. But you have like these designs, whatever you want, you can decide, okay. So this is what connection panes like. If you want to show many inputs, you can right click on this, okay, and then you will get this pattern and you just select which one you want, okay. And now you want to connect inputs, you click here first, your arrow becomes like a wire, and then you click here. So this connection is linked. Then you click here, then you connect here. So it will be like linked together, okay. So this way, if you have like many inputs, like 10 inputs, you do it one by one like this, okay. And next thing, one more thing is there. You see this one particular thing here, okay? So when you click on one point, you can decide this as required or as recommended or as optional, okay. So this will make your VI to have some constraints. Like for example, if you design and say it like it is required, okay, it will be like this VI will never run until you supply that input, okay. Recommended is like another option where it is like if you supply it's okay, if you don't supply it's okay, also like that. Optional is you have already your own data inside the VI. So if you supply, that data will be used. If you don't, then it's like no problem with that, okay. But if you select required, you have to supply the data for that particular VI. So for example, we designed this degree centigrade to Fahrenheit, okay, and I mentioned that this value should be required, okay. When I say that this point is required, okay, and when I see in its context help, I will be saying like this temperature in it's in bold space, okay. It is means like it is required. Means in context help, you will see these different notions, like, you know, if it is required, it will be appear as a bold. If it is recommended, it will be like this normal font, okay. I will give one more example. What is this? You see, so I designed one SubVI, okay. This is its context help, okay. So I mentioned is as a required one, okay. So in context help, it is appeared as a bold, yes.
Yeah.
And when I make recommended value, it is like asking the user or programmer that you can supply this value, is okay. If you don't, it's okay. So it's no problem. So when I put this VI on my block diagram, sub VI, as it is a required value, and I am not giving any value to this program is not going to run, okay? Because LabVIEW knows that this VI needs this particular value as required, okay? So until I supply this value, its program will not run, okay? So same thing happens here. This same VI, I supply some value to that particular VI, okay? Then now it's all error is gone, okay? So now I can run this VI, yes? So
Okay.
when we design a SubVI and we decide like this is required or recommended or optional, you see I designed one optional here also, okay? But optional doesn't appear in our context help because we mention it as a optional value, okay? But when we click on a detailed help, it will show you the what is the option of optional here, okay? So this is how we design and we make the LabVIEW understand that this value must be provided so that this SubVI will run. Okay? So if you are not providing value for that, then SubVI will not run. So this is what we decide. Okay, this is when we do make a SubVI, we decide that yeah, this must be there or this not. This is okay. Okay, so I will show you one VI. We designed one VI, then we have some SubVI.